want to talk about the maclaurin series. Uh, After the previous one, I talked about the Taylor series. So today we talk on the maclaurin series. So first, a maclaurin series is a Taylor series. Is a Taylor series that is centered that is centered at zero. So which means uh, this means that its general formula will be of this form, which means the center is zero as we have defined it. So this is its general formula. Okay, this is the general formula. So let us look at one example of how we can solve a problem under the maclaurin series. So example one, find the maclaurin series of e exponential. So obvious the center is at zero since this is a maclaurin series. So first we list the derivatives of this. So the first derivative of this, according to the law of derivation, we find that when you derive e exponential, it still remains the same, and this applies for the second derivative and to all the others also. So we have realized that when we derive e exponential for the first derivative, second derivative, third derivative, and the fourth, and even if when you go to the fifth, sixth, it still remains the same as the e exponential. So let us look at the centers now. You can see that the center of this series is at zero since it is a maclaurin series. So we'll replace the center we'll replace the center with zero. And now if you derive zero, you'll get one. And for the second derivative of zero, you'll get one. The third, it will also be one. Fourth, it will also be one. And this goes up to infinity. So after doing this, now we can try and open our series. Let us try and open it. So uh, our series, the maclaurin series, is in this form. So we'll have to break it to be simple. Now when n is 0, uh, here will be raised for 0, and it will also be 0 factorial, which means this is, it will just remain like this. It's 0. Yes. Again, let's proceed. When n equals to 1, we'll find that the series will now be in this form, that x raised to power 1 over 1 factorial. When n is 2, it will be x raised to power 2 over 2 factorial, and this goes up to infinity. So if you look at where, uh, if you look at where we started from, you can see that we were dealing with the e exponential, and now since this one is the factor that we are dealing with, we'll replace it here. So it will be e exponential equals to ex over x raised to power 0 over 0 factorial. That is when n equals to 0, and then plus e over x when n is 1 raised to power 1 over 1 factorial, plus x squared over 2 factorial, and this goes up to infinity. So you can see that x here is common, e also is common, but this is the factor, so we may not include it in the overall formula. So we find that the overall maclaurin series of e exponential is factor, which is centered at 0, that is e, it is centered at 0, x, since x is common, we put it here x, and we can see that the powers also vary, 0, 1, 2, they vary, and it can also be 3, 4, 5. So we represent it with the n, so it will be x raised to power n, since the powers vary, over n factorial, since also the factorials vary, 0, 1, 2, 3, and so on and so forth. So this is the overall formula of the maclaurin series of e exponential. Thank you.